All right, well, welcome to Chapter 7. We're working with polynomials this chapter, and I hope these notes are useful to you. I will take comments at slarson3@c-ischools.org. This first lesson I'm going to call Apples and Oranges. Our main topic is polynomials and adding them. The reason I'm saying apples and oranges is that you're going to have to learn as you look at polynomials which ones are alike and which ones are not. And so we're doing two main things here. Number one, we're going to describe. Number two, we're going to add. Now, some people say add and subtract. I would prefer to think about always adding, just that when you see a subtraction that you change it to adding the opposite. When we say describe, if I can go back one other thing here, we describe polynomials, and more on what is a polynomial in just a moment, but polynomials can be described two different ways. Number one, they can be described by their degree and by their terms. A couple of things. A degree is referring to the exponent, and the terms are referring to looking for plus or minus signs, and that tells you how many terms there are in each one. For example, before I go to the reminders, let's just write out a polynomial here. Let's say we had 3x to the fourth power minus 2x plus 1. Here we have three terms, and in each term we have some numbers. Remember, the 3 in the front and the -2 here are called coefficients because they're each attached to a variable. The 1 is referred to as a constant, and when we say degree, we are talking about those little exponents. So this has an exponent of 4, and there's an exponent of 1. So that's when we talk about the degrees, that's what we're looking at. Again, it has 3 terms. These are each a term. All right, before I dive into the problems, just a couple of reminders. And again, when you see a problem that is a subtraction problem, like 7 minus -8, think about always changing that to 7 plus, and then we change the sign of the number after. If it's a negative, it becomes a positive. If it's a positive, it becomes a negative. So in this case, 7 plus 8 is 15. That's going to be very useful as we move forward. And then second of all, when you add two things together, like x plus 3x, keep in mind these things are both apples or both oranges. They're alike, and so we can add them together. You just have to keep track of the coefficients that are in front. So 1 plus 3 is 4. Again, don't change the exponent on the variable. Just leave it as 4x to the first power in this case. And we don't even need to write that because it's understood to be a power of 1 if it's missing. Okay, so two reminders: subtractions, and when you add things together, look at the coefficients and just add them up. All right. Again, remember the two goals that we're describing and adding. Vocab. Polynomial is the first maybe vocab, and this is something that has many terms. So a polynomial can have like one term. If it's one term, then it's called a monomial. Notice that word mono in front. This would mean one term. Guess I need to do a little erase in here. Let me get rid of that. All right. So this is just one term. Binomials have two terms. And a trinomial can have 3 terms. The one that I just wrote off to the right and erased part of, you can still see the last two terms on it, was a trinomial. Now that I've erased that other term, it's a binomial. Okay. So again, that's looking at a polynomial by its term. If you look at a polynomial by its degree, then we look at what's called the exponent. And that exponent, if the exponent is 0, then we call that a constant term. If the exponent is 1, nearly every problem that we worked on in the first trimester was of this fashion. They were linear, and that's because they create lines, and the exponent is 2. This second trimester, you're going to be working a lot with quadratics, and those all have degree of 2. Finally, we're going to do just a few of these. You might see them graphed. More on that in Algebra 2. Cubic equations, they have degree 3. And there's higher ones too, but those are the famous ones. Those are the ones that we name. Those are the names that you are expected to know. Again, two sets of ways to qualify a polynomial. You can do it by its term. You can do it by its degree. All right. Our first example here. Find the degree of each. Notice this is a monomial. There's only one term. And if we look at the monomial, we don't see a power, but we remember from the last chapter in 6 that there is a power here. It's unspoken. Better not draw a 0, maybe just put a little gray area there. The exponent is 1. So in this case, I don't want to say the degree, the polynomial equals 1. I want to say, just draw maybe a little arrow and say the degree is equal to 1. Our second example. It looks possibly like a binomial because we see two variables, but in this fact there's no plus or minus, so we still only have a monomial. But in this case, our degree has gotten larger. Now, you might think, oh, the degree is just 3 because we see the 3 there. But in effect, we actually have two variables here. And so we have to remember that there is a 1 there. In this case, we're going to add those two exponents together and get a degree of 4. Here now we have not a monomial, but we have two terms. We have a binomial. And so our degree in this case is not 2 plus 4, but rather just the degree of the larger term. Because whenever you look at a degree, it's always going to come from one of the terms, whichever one happens to be the largest. So don't pick 2, but rather 4. And our last example here, I don't know why I called them A, B, D, and E. I guess I forgot letter C, pardon me. Example E, it looks like it's got a variable, but there actually is no variable. Remember that pi is a constant. And so because there is no variable, our degree is just 0. Don't get fooled by that 2. That 2 is affecting the pi, not a variable. Notice there's no letter there. All right. So, finding the degree of each term, you look at each term separately and find the power. If there's more than one variable in the power, add them up. All right. Example 2. We're going to write them in standard form. That's an important piece of information. And then we need to describe by both terms and degree. All right, example number 1. Standard form means that we look at the 3 terms, and whichever one has the highest power, that is what we write first, and then we write them down in descending order. So in this case, I'm going to write the 5x to the second power first because it has a power of 2. Then I'm going to put my negative x. Notice how I changed that to a plus negative x. You could write it as a minus x if you would like to live dangerously. And finally, I'm going to put the 4 at the very end as the constant. It has no variable. In fact, it's disappeared because the power of that variable is 0. Example B. We have just two terms. Oops, hang on, I got to go back. I forgot. We need to define by terms and by degree. So in this one here, I'll put a semicolon here, and then we'll say the terms are 3. So if we look back at our list and find the word that matches 3, we see that this is the trinomial one. Yeah? All right, so this is a trinomial. And finally, if I look at the degree of that one is 2, is the highest exponent. Okay? Again, looking at the powers, at the exponents, if it's a power 2, we call it a quadratic. Okay? So the degree is 2, so it's a quadratic. All right, so there's the 3 answers that I need. Again, writing it in standard form, the number of terms, and then the degree. Looking at example B, here we'll go a little bit faster. Again, we put the 4z in front. Watch out, don't forget about that negative sign that travels with it. Plus 9, so the exponent again has a power of 1, so that gets ahead of the 9. It's more important, it has more influence on the problem. Terms, hopefully you can see that there are 2 terms, so we refer to this as a binomial. And finally, since it has a degree of 1, we call that a linear function. And example C. Again, the cubic one goes first. Again, bring the negative sign with it. Plus t. Again, there are 2 terms. So it too is a binomial. And finally, if we look at the degree of this one, we can see that the degree is 3. So we call this a cubic function. All right. Last 2 examples, and we're done with our lesson. We're going to add. Now notice the first problem is an add problem, and the second problem is a subtract problem. But we're going to change that second problem to an add problem so that everything's add, and we're just going to add the opposite. All right. There are several ways to think about this. When we add, this is where the apples and the oranges come into effect. We don't want to add things that are not alike. So for example, you can't add 2x cubed to 5x squared because their exponents on the variables are different. So we're going to look for things that have the same exponent. And so I see, okay, well, I've got a 2x cubed, and let me take a pen here and just circle all the cubes. And so I have a 2x cubed and a x cubed. Remember that there's a 1 in front of the x cubed. Therefore, if I have 2 plus 1, I have 3 x cubes plus. Next, I'm going to take my x squareds. Notice we have, looks like we've got 5. But if we stare carefully, we see that little minus sign there. So we're going to change that to plus negative 5. And I have a 5x squared, and then I've got another 2x squared here. And just so it doesn't get quite so confusing, I'm going to put that arrow down here. Yeah, those 2 things go together. And together they give me negative 5 plus 2 gives me negative 3 x squareds. Finally, I have an x and a negative 1, And neither of those are alike, so we can't combine them. So we're just going to add those two things on at the very end. Again, notice how I changed the -1 into a plus -1. It's going to help you down the line if you keep track of that as a plus, not a minus. Last example. Again, this is the tricky one. If you're to make a mistake in the problems, this is where you're going to make the mistake. Subtracting a problem is the same as adding the opposite. So when you see a minus sign in front of a set of parentheses like that, what we'll want to do is change the signs of everything. So again, if I'm going to subtract -2, what I like to do is put that, change that to a plus and put a negative sign in front there, and then I just draw a little arrow to each term, showing that I'm going to distribute that. So this is going to become a positive 2n squared, and this is going to become negative 2n. And then we're going to get a positive 4. All right. So now we're going to add 4n squared plus 5 to all those pieces there. Some people like to line them up right below too. Some people want to take, for example, the 4n squared and put that right there, for example. And then take the 5 and put the 5 right there. And then add them up like in the old days when you did things vertically, right? You certainly can do that if you want. I like to just highlight the ones that are the same, and if you want, you can use different techniques like underlining with 1, and then underline with 2, and then underline with 3, anything else that is similar to keep track of visually the things that you're adding together. 4n squared plus 2n squared, 6n squareds. Don't put the 5 next because that's the constant term, so we're going to leave that for the very end. Notice we have a negative 2n here, so that's the next term I'm going to write down. And then finally 5 plus 4 is 9. I should circle your answers, block them out, whatever your teacher thinks is an important way to show I have arrived. All right, well there's a little introduction to polynomials, learning how to classify and how to add and subtract them. This is just the beginning of a rather long